Well, now we have a quadratic equation to graph, and we know any quadratic equation can be written in this form: a times x minus h, quantity squared plus k, where the vertex is at hk. So with that in mind, we now know the vertex for g of x is at the opposite of positive 3 is negative 3. Negative 3 takes that to 0, that expression, and the y-coordinate is 5. So we've got the vertex. Let's find the y-intercept. So we'll evaluate g of 0 to do that. And that equals negative, and replacing x with 0, we just have a 3 in the parentheses. We're going to square that, and there's our plus 5. So that equals negative 9 plus 5, which equals negative 4. So the y-intercept occurs at 0, negative 4. Now for the x-intercepts. To find those, we set g of x equal to 0 and solve. That means 0 equals, and our g of x is negative the quantity x plus 3, quantity squared plus 5. Now we'll add this term to both sides. That is, we'll add the quantity x plus 3 squared to both sides, quantity squared to both sides, and we get x plus 3 quantity squared equals 5. So by the square root property, x plus 3 equals plus or minus the square root of 5. And isolating x, we get x equals minus 3 plus or minus the square root of 5. So the x-intercepts occur at negative 3 minus the square root of 5, 0, and at negative 3 plus the square root of 5, 0. Now we're ready to graph. So here's our x-axis and our y-axis, and while we're at it, we'll graph that y-intercept. That's at 0, negative 4, and the vertex occurs at negative 3, 5. So here we are at negative 3, 5, and it's a parabola, so it opens down, going to go through 0, negative 4, and it's symmetric about this axis of symmetry, and the axis of symmetry is x equals negative 3. So this point here, this x-intercept is negative 3, negative root 5, 0, and this x-intercept occurs at negative 3 plus root 5, 0. And let's see, we've done the intercepts. What remains to be done, we've got to identify the domain. So the domain equals. Now, this is a polynomial. There are no variables in the denominator, so we have no possibility of division by 0. Also, there are no square root symbols involved in this, so there's no possibility of taking the square root of a negative number. So the domain is all reals, and in interval notation we have negative infinity to infinity. The range is going to be y such that, now the maximum y value on this graph is 5. All other y values are less than 5, so y is less than or equal to 5, and we've done the range. In fact, we've done the problem. We are done.